Section 3 in Chapter 9 is about rotations. So by the end of this lesson, you should be able to identify and draw some rotations. Remember, isometry is a transformation that doesn't change the size or shape, so everything that we're going to draw is going to be congruent to its pre-image. So we've already done reflections where we flip something across the line, and we just did translations where we slide things along a vector. Rotations are the hardest. They're where we turn something around a point. So if this is a point we start with, and this is the point of rotation, and we want to turn something, this is the angle of rotation that we have right here. And this is where a new point would be. So first thing we gotta do is tell whether each transformation appears to be a rotation. So this first one right here would mean that the star's stuff would have to look turned, like somebody picked the red one up and just started spinning it. And no matter how we spin it, even if we spin it all the way around, it's never going to look like this because this is a reflection. Where this one, if you start with the blue one, you can see that it just took some spinning to get all of this stuff turned over, and it's exactly the same shape, we just rotated it a little. So here's our formal definition. A rotation is a transformation about a point P called the center of rotation, this point right here, such that each point and its image are the same distance from P. So the distance from A to P is the same as A prime to P. And such that all angles with the vertex P are congruent. So if we had another shape, this angle would have to be congruent to it. In the figure, angle APA is the angle of rotation. So unless otherwise stated, all the rotations that we're going to do are counterclockwise. I know that seems backwards, but really the clock is the only thing that goes clockwise. So counterclockwise in math is usually the right way. So we're going to do three main transformations. We're going to do 90 degrees about the origin, 180 degrees, and 270, which is a combination of these two. So in a 90-degree translation, what you're going to do is you're going to flip the x and the y values around, and then you're going to change the sign on your y value. So if this point was over 5 up 2, this new point would be, switch them around, 2, 5, and you make this negative. And if you stop and think about why that makes sense, is because when we do this, our new x value has to move over into negative x land. So it makes sense that I went negative 2 and then still up a positive 5. Where if you go 180 degrees, it's like you're translating around the origin. You keep x and y the same, but then you make them negative. So again, if this point's 5, 2, the one over here would be negative 5, negative 2. And again, stop and think about it. It makes sense. You're in negative land in x's and negative land in the y's. And then 270 degrees, your book doesn't have a nice, pretty picture for it. But 270 is like I took this one here, and I'm trying to put it over here. So just like for 90, you're going to switch these guys around. So it becomes negative y, negative x. And then we got to make it positive, and make it positive, make one of them positive so that it makes sense. So that's going to be this guy here. So let's rotate this triangle 180 degrees about the origin. So first let's put this triangle on there. 2, 2 is J. 4, negative 5 is K. And then L is negative 1, 6. So this crazy obtuse triangle that we have going on here. 180 degrees about the origin. So what we're going to end up doing is, if we look back here, all we got to do is make our x's and y's negative, and that will rotate it. So our new points are going to be J is going to be at negative 2, negative 2. K is going to be at negative 4, positive 5. And L is going to be at positive 1, negative 6. So if we go to plot these ones, negative 2, negative 2. K is at negative 4, positive 5. And then L is at positive 1, negative 6. So we can see the shape is congruent to the one we started with. It just got rotated. So this is J prime, this is K prime, and then this is L prime. So let's do another one. Rotate RST about the origin 90 degrees. So we'll start with plotting these points. There's R, S is at 2, 1, and then T is at 3, negative 3. So 90 degrees means that it's not going to totally flip over, but it's just going to turn just a little bit this way. So if you go back to this, 90 degrees means we switch our x's and y's, and then we make the first one negative. So R prime, switch the x's and y's around, so it's 4, negative 1, and then change the sign on the first one. S prime, you switch the x's and y's around, you change the sign on the first one. And then T, switch them around, you change the sign on the first one. So then we can graph these. Negative 4, negative 1 is my new R value. S is at negative 1, positive 2. And then T is at positive 3, positive 3. So you can see that it turned, just like we had this arrow here. So R went from here to here, S went from here to here, and T went from there to there. And if we were to measure that, that would be 90 degrees for each of them. So let's do a tough problem. Let's say we have a Ferris wheel. It has a 100-foot diameter, and it takes 60 seconds to make a complete rotation. A chair starts at 100, 0. After 5 seconds, what are the coordinates of its location to the nearest tenth? This should say 100-foot radius. If not, that's going to make this problem a little different. So we can draw ourselves a picture. We can impose the X and Y axis on this. 100-foot radius means that if a chair starts out here at 100, 0, they start at this point, which means the angle of rotation is 0 at this point. So 100, 0. Now after 5 seconds, I want to find the coordinates. So 5 seconds, it's going to start moving. It's going to chug up, 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 and then it's going to be somewhere around here. It's our job to figure out where those points are, where this X is and where this Y is. So in order to do that, we got to think about a couple things. First of all, because this has a 100-foot radius, it doesn't matter where a point is on this line, this distance is always going to be 100. Now what we really want to find is the X values and the Y values. So we can make this nice 90-degree angle, and we have to find this angle right here. So in order to do that, we're going to use this information. So all the way around, to make a whole circle usually takes 60 seconds. We're just going 5 seconds. All the way around is 360 degrees of a circle, so we can figure out how long 5 seconds of a circle is. So if we do some quick math with this, 360 times 5, we end up with 1800. Divide both sides by 60. And we end up with 30. That means that this angle right here has to be 30 degrees. And in 5 seconds, it travels 30 degrees. Now, like this said back here, that if the angle of rotation is not a multiple of 90, we can use sine and cosine ratios to find the coordinates of our image. So that's what we're going to do right now, is use sine and cosine ratios. So I'm going to relate everything to this hypotenuse, which I know is 100. So if I want to figure out the X value first, that is going to be the cosine of 30 is adjacent over hypotenuse. And if you do 100 times the cosine of 30, you end up with about 86.6. So this point up here, the X value is about 86.6. And now let's figure out the Y value. So I'm going to use sine of our same angle of 30 as our opposite over hypotenuse. So throw that in our calculator, and we end up with 50. So now I know after 5 seconds the coordinates of my location are at 86.6, 50. And that's it. You should be able to identify and draw some rotations. Write down any questions you have, and we can go over them in class. Enjoy your night.